Aldehydes and ketones, both compounds bear the carbonyl group. The aldehyde has at least one H atom, hydrogen atom, bonded to the carbonyl group. Now, aldehyde is often written as RCHO. This is the structure of aldehyde. It's a carbonyl group, has one hydrogen bound to carbon. It's the R group. A ketone has two alkyl groups bonded to the carbonyl group. Ketone is often written as R1COR2. This is the structure of a ketone. It's a carbonyl group here, and this carbonyl carbon bond two alkyl groups, R1 and R2. Structural features of the carbonyl group. The carbonyl carbon atom is a trigonal polymer, and the all bonds angles are 120 degrees. Look like the carbonyl carbon bonds three atoms, the oxygen and the two carbons. So this is a trigonal polymer with the bond angles 120 degrees. Carbonyl group is a dipole with the carbon atom partially positive and oxygen partially negative, the dipole. Next, let's take a look at how to name aldehydes. In the AUPAC system, aldehydes are identified by suffix al. Find the longest chain containing the CHO group. This is the aldehyde group, and changes the E ending of the parent alkene to the suffix al. Name the parent chain to put the CHO group CHO at the C1 position, but omit the number from the name. Apply all other rules of the AUPAC nomenclature. Let's take a look at two examples here. This one is a 2,3-dimethyl-butanol. The parent chain has 4 carbons, so it's called a butanol. And two substituents, 2 methyl groups at position 2 and 3, so it's called a 2,3-dimethyl-butanol. This one is this parent chain has 1, 2. Start from here. 1, 2, 3, 4, 5 carbons. This carbonyl group carbon is a C1, so it's called a pentanol. At the 2 position has an acyl group, so it's a 2-acyl pentanol. Let's take a look at the common name of the aldehyde. The following aldehyde compounds are using their common names. This is formaldehyde, only 1 carbon. This acetaldehyde, 2 carbons. And this has a benzyl ring, the benzaldehyde. Okay, has a benzyl ring here. It's a aldehyde group and the benzyl. Next, let's take a look at the naming ketones. In the AUPAC system, ketones are identified by the suffix ONE. Find the longest chain containing the carbonyl group and change the E ending of the parent alkene to the suffix ONE. Number the carbon chain to give the carbonyl carbon the lower number. And take a look at this example here. This butanol. The parent chain has 4 carbons, and give this carbonyl carbon the lowest number. So this is 2, 1, 2, 3, 4. So there's 2 butanol. With the cyclic ketones, number the carbonyl carbon as carbon 1, but the number is omitted from the name. Take a look at this example. This is the 3-acyl 4-methyl cyclohexanol. Hexanol means it's a ketone. Cyclo is a cycloketone. Put the carbonyl carbon as a C1, and this apply all other usual rules of the UPAC nomenclature. That means when we put the C1, the carbonyl carbon as a C1, other substituents have a lowest number. So, and this is 1, 2, 3, 4. So those substituents has the number 3 and 4. At number 3 has an acyl group. At number 4 has a methyl group. So this compound is called 3-acyl 4-methyl cyclohexanol. Common names name both alkyl groups on the carbonyl carbon alphabetically, and then add the word ketone. This is the common name for this molecule. It's acyl methyl ketone. Reactions of aldehydes and ketones. The first one, oxidation of aldehyde. Aldehydes has hydrogen bonded to the carbonyl carbon. They can be oxidized to carboxylic acid. Ketones do not have the hydrogen atom bonded to the carbonyl carbon. They are not oxidized at the same condition. Ketones can be oxidized by strong oxidizing agent in a destructive way, breaking carbon-carbon bonds. This is aldehyde, and oxidized into carboxylic acid. This aldehyde group is a carboxylic acid group. Next, let's take a look at reductions. Reduction of aldehyde and ketones. Reductions results in a decrease in the number of CO bonds and the increase in the number of CH bonds. Aldehydes are reduced to primary alcohols. Ketones are reduced to secondary alcohols. Reducing agent is a hydrogen molecule in presence of this metal is palladium, Pd. This is reactions. This is aldehyde. Aldehyde is reduced into a primary alcohol. This is the primary alcohol. Only have one carbon-carbon bond. A ketone is reduced into a secondary alcohol. This carbon has 2 carbon-carbon bonds. Secondary. Acido formation. Aldehydes and ketones undergo addition with alcohol to form hemiacetones and acetones. Take a look at this. This is the aldehyde. This is the aldehyde if it's the H here, it's the ketone if it's the R here, and then interact with the alcohol to form this compound. And add the hydrogen here, and the alkyl group on the carbon. Okay, and add hydrogen on the oxygen, and the alkyl group on the carbon. And then this is called hemiacetals. And then they can go further, add another alcohol molecules. Add the R prime, replace this hydrogen with R prime to form this acetal and water molecules.